All right, so that's last section in Chapter 8. Those doing the final exam project, last section of stats you are required to learn. And this is on 8.6, a significance test for a mean. So again, this is where we take the section 8.5 stuff and put it into the 4-step process. Okay. All right, so again, the inference method here is called a one-sample t-test for mu. So that's going to be in the plan step. And again, I got my table B all ready for that t. And again, remember, that's for population means. All right, here we go. Example 1, are these subs too short? Abby and Raquel like to eat sub sandwiches. However, they notice that the length of the 6-inch sub sandwiches they get at their favorite restaurants seems shorter than the advertised length. To investigate, they randomly selected 24 different times during the next month and ordered a 6-inch sub. Here are the actual length in inches of each of the 24 sandwiches along with the dot plot of the summary statistics. Do these data provide convincing evidence at the alpha equals 0.10 level that the sandwiches at this restaurant are shorter than advertised? Okay, so I have some space to work with. Okay, so I am gonna, how am I gonna do this? So we'll start here. I'll just try to use the space I can. Sorry if it looks clunky. All right, so it might just go all over the place. So we're gonna state. So we want to perform a test at the alpha equals 0.10. That's kind of high, but that's okay. At the alpha equals 0.01 significance level of and now we're going to put our two hypotheses, our null, it involves a mu equal to something, and our alternative, mu could be greater than, less than, or not equal to some number. So we are measuring the length of a 6-inch sub. So I believe that 6 inches is the standard. That's going to be your null value, 6. And again, they think that their 6-inch subs seem shorter than advertised. So they're trying to see if in their population, in this sub sandwich shop they go to, their favorite one, if they're actually getting less than 6-inch subs. Where mu equals the true mean, true mean length, right? That the sandwiches at this restaurant are shorter than advertised on average. So where mu equals the true mean length of all 6-inch subs from their favorite restaurant. From their favorite restaurant. I noticed that on the 8.4 homework, a lot of us were not including the specific population, right? So we are not looking at all 6-inch subs in the known universe. No, we are focused on the ones at their favorite restaurant. So make sure you talk about that in the where when you're defining the parameter, and also in the conclude when you're concluding. So again, this phrase we will use again in the conclusion. Okay, so I'll try to leave that up there as much as I can. All right, next is the plan. So let's do it right here in red. I'll try to change colors. Red. So plan. So we're going to do a one-sample t-test for mu. All right, that was the inference method we just talked about. We are going to do the random condition. So for the random condition, I see they randomly selected 24 different times during the next month. Randomly selected 24 different times during the next month. So, and we should say in order to 6-inch sub, but that's good enough for me. They randomly selected 24 different times. So it is a random sample. And now with means, the other condition we have to check, I'll do it right here, is the normal large counts. Remember that there are 3 parts to this. Only one has to be true. Number 1, you can be told that the population is normal. In these words, I see no normal anywhere, so it doesn't count. Or the normal condition we cannot use. Next is the large counts idea. Do we have a sample size greater than or at least 30, right? Greater than or equal to 30. Nope. Sample size is 24, right? So that doesn't work. So next we have to look at the dot plot. And if I look at this dot plot, let's see, right? So I see mostly a bell-shaped curve. Again, it's not a perfect bell, but it's not strongly skewed. And I see no outliers, no numbers way off by itself. So it does pass the normal large counts condition because the dot plot of the sample data shows no strong skewness or outliers. And there you go. All right, nice. Okay, so now let's go ahead and do the do part. So this is going to go away. You can always pause it if you need to. All right, so now we do the do part. So we need to come up with the standardized test statistic, which is the t-value. Before we do that, we need to identify a couple things. First, my sample size is 24. My x bar, my sample mean is 5.677. My sample standard deviation is 0.657, and my null value is 6. Okay. Now we are going to plug it into this formula. So t equals the sample value of 5.677 minus the null value of 6, all divided by this fraction, 0.657 over the square root of n, 24. Okay, so I'm going to show you how to type this into the graphing calculator here in a second, and maybe we'll finish all our work there. Let me take a picture so I don't forget. Okay, so I'm coming here to the graphing calculator. And again, this is to get my t, my test statistic. So fraction, I'm doing 5.677 minus 6 all over a fraction, 0.657 divided by the square root of 24. And I get a t-value of negative 2.408. So that is my t. So your t-value is negative 2.408. Now on the table B, you have to think of this as a positive 2.408. Again, we are thinking it's less than that. So our negative t-value is here. So we're looking for that probability, that area. But it's going to be symmetrical to this over here with the positive t-value. Okay, so be aware that that is what table B shows us, the right side, the positive. So now we take this value of 2.408 in our degrees of freedom. Our degrees of freedom is n minus 1. 24 minus 1 is 23. And we go to table B and we try to find the two values that surround this t value of 2.408. So let's go do that now. So I'm here on table B. 23 is my row. Let me blow this up a little bit. Ooh, I got pen too, so I can do that real fast. Cool. All right. So my degrees of freedom was 23. So this is my row. And I'm looking for 2.408, I believe. Let me just double check that. Yep, 2.408. So if I look in here, right here, these two surround 2.408. So I would write on my notes here, I'd put table B, and I would put the two values of 2.177 and 2.500. Then I would write p-value equals, let me see if that different color shows up better. How's that work? Yes. So let's do that. Table, again, this is table B, 2.177 to 2.500. And then my p-value, I would put the two values here and here. Now remember, they're not numerical order, so flip-flop them. So 0.01 to 0.02. And since it's a one-sided test because my alternative hypothesis was mu less than 6, I keep that. This is my p-value. So my p-value, what I'm really looking for, is between 0.1 and 0.02. Sorry, 0.01 and 0.02. So that's the end of my do section. Okay. So now I go back to my notes and let's do the conclude, and then we'll be all done. Okay, so what do I want to conclude? Well, for my conclusion here, and I'll do it right there, we always start with our p-value. So the p-value of 0.01 to 0.02 is less than our alpha value of 0.10. And because it's less than, we have convincing evidence, so we reject the null. There is convincing evidence that, and this is where you restate the state part, that the true mean length of all 6-inch subs from their favorite restaurant is less than 6 inches. And there you go. And that's the conclusion. And that's what we really care about. And again, it's for their favorite restaurant. That was the population we looked at. So they might want to choose a different restaurant. Okay. Very good. So they're kind of longer problems, but not too bad. All right. I'm going to stop here. I have a second example as well in this objective, but it's going to take too long to do. So I'm going to stop, make another video. All right, good.